Hello, greetings. I hope you are doing well. If you are new to the channel and you haven't subscribed, please subscribe. And also, if you are new to the topic, feel free to visit my previous videos under calculus. So today we are doing revision of some 3 basic questions under calculus related to what I had discussed with you in the previous lesson. So as you can see, I've tried my best to come up with a question, and at least it is now much better because I don't have to read a question then do without you guys seeing where the question is coming from. So having this is at least better, and it is because of your participation, commenting back to my channel, giving me that motivation to do much better. So I thank you all. And let us continue that way. So question 1. The sketch below shows curve y equal to 2x squared plus 4x plus 3 and a straight line intersecting the curve at point A and B, as you can see. If the x-intercept is negative 3.5 and the y-intercept is 7, find the equation of the straight line. So this part was never indicated. The x-intercept here is a negative 3.5. That is the x-intercept. Now, find the equation of the straight line. For you to get an equation of a straight line, you must have the coordinates of a particular line. So the coordinates in this part, remember this is the beginning of our Cartesian plane, which is 0, 0. So that means our coordinate for the x will be what? The x then the y will be negative 3.5, 0, and what will be the y-intercept? The y-intercept will be what, guys? Y-intercept will be 0, 7. Having this is enough for us now to get what? The equation of the line. So at this point we get the gradient. The gradient will be the gradient of this point will be given by 7 minus 0 all over what? All over 0 minus 3.5. So we have 0 all over 3.5. So what is our gradient? I'm sorry. So I'll have to rub some, but don't worry. So our gradient here will be what? Our gradient will be 2, if I'm not wrong. 2. Our gradient will be 2. So if our gradient is 2, let us pick any of the coordinate. In my case, I'll pick this one. Though the answer will still be the same, Let me pick this 0, 7. So using 0, 7, I will be having 0, 7 x, y, gradient is equal to 2. That means that y minus 7 all over x minus 0 is equal to what, guys? Is equal to 2 all over 1, which is the gradient. So you cross multiply. Doing that, we shall have y minus 7 equals to 2x minus 0. So that means the equation of the straight line, will be what? Will be y is equal to 2x plus 7. Coming to part B, find the coordinates of A and B. Remember, here, for this question, a curve and a line are intersecting a curve and a line are intersecting. Are you seeing? A curve and a line are intersecting, and that means they are equal. When two things meet, let me tell you mathematics secret. When two things meet, that one means that they are equal. They are equal. So that means we equate the function and the equation of the line. So the function was already provided, and this 2x plus 7 is our equation. Now, I have already told you that when two things meet, that means that they are equal. So that means the function 2x squared plus 4x plus 3 plus 4x plus 3, this function above, this function, it is equal to the equation of the line, which is 2x plus 7. The main reason I'm doing this is to get the coordinates of A and B. So I now collecting like terms, just a simple algebra. So I shall have 2x squared, 4x minus 2, that one is plus 2x plus 3. Sorry. This one coming this other way will be what? Will be minus 4. Minus 4 is equal to 0. So 2x squared plus 2x minus 4 is equal to 0. Then we use the quadratic formula. The easiest one, the quadratic formula will always be negative b plus or minus the square root of b squared minus 4ac all over what? All over 2a. So this one is a, b, and c. I left a small space, so you will excuse me to squeeze my questions, please. So we are having this negative 2 plus or minus the square root of b squared. B squared there is 2. So we have 2 squared minus 4 multiplied by a, which is 2, multiplied by c, which is negative 4, all over 2a, multiply, which is 2 times 2. So allow me just get the answers, please. Allow me just get the answer, because I'm sure you can get those one. So my x1, just punch that one in a calculator. My x1 will be 1 or x is equal to what? Negative 2. Remember, this is quadratic, so you must have two answers. Then you come and say, after getting those values of x, you come and say, when x is equal to 1, what is y? And when x is equal to 2, when x is equal to 2, when x is equal to 2, what is y? So you go back to the function. You can either use the equation of the line or the function. They'll all still give the same answer. You can either use the curves function or you use the equation of the line, this other one. They'll all still give the same answer. Now, when x is equal to 1, y will be what? Y will be 9. And when x is equal to negative 2, y will be 3. Then after having this, you now come and reason with the question. What do you think a can be? What do you think the coordinates of a can be? Remember, it is this. The coordinates is coming down all the way to that point and crossing that point. For b, it is coming this side, then to the y-axis there. Then now, if you look at a on the x-axis must be negative, and on the y-axis positive. So come and look at a. A could be this other one, minus 2, 3. So that means coordinate A will be minus 2, 3. And what about B? B will be obviously the remaining one. That is 1, 9. That is 1, 9. That is 1, 9. So that is the coordinate of A and B. That is the coordinate of A and B. Calculate the area of the shaded region. The area of the shaded region. The region that was shaded here was this part. I never indicated that one. So this was the part shaded. So calculate the area of that shaded part. Calculate the area of that shaded part. Now, I want you to note this. In such type of a question, the equation or function that appears at the top is the one we are dealing with, or subtracting one from the other. What am I trying to tell you? Or what am I trying to say? What am I trying to say? For us to get the equation of this shaded part, first of all, we must get the area of this whole function, then the area of this this line, which will be tiresome. It is not easy for you to get area of a line, but at some given point it is easy to get the area of a curve. But that one is very long. I have a short formula to give you. For you to do that, you must subtract. So you will subtract what? Remember what I told you in the last video. You must just after just video before this one. Feel free to check it back if you didn't understand me. There's something I told you there. There's something it was the last talk that I made. Now, how do we get this? You must subtract. You must subtract. So we are subtracting the line from what? Sorry, we are subtracting the line to the function, or subtract the function from the line. So we shall have something like this. We shall have something. So the equation of the line was 2x plus 7. Then you subtract. Remember, the shaded part is just a section. The shaded part is just a section. So that means if we were to get the area of this whole function, of all this curve, then it will be from this point to that end point, even the part covered. But we don't want that. We only want a section of it, a section of the part which is shaded. That small part only. So that means we are getting the difference in between the line and the curve for us to remain with the part that is shaded. I hope you are understanding that one. So we shall have 2x plus 7 minus 2x squared plus 4x plus 3 plus 4x plus 3. Remember to include the bracket because you are subtracting, and you must only subtract a line to a function. Not a function to a line, but a line to a function. So we shall have what now? 2x plus 7 minus 2x squared minus 4x minus 3. You must put a bracket when you are subtracting this way. So collecting like terms here, we shall have minus 2x squared minus what? Minus 2x plus 7 minus 3, that one is 4. So plus 4 equals to 0. Now that one equals to 0. Then now we integrate, because we wanted the area, we integrate. Remember, we wanted the area of the shaded region. So shaded region, okay. Remember, at A, we are having 2. Then at B, we are having what? This one should be 1. Then here we are having 9. So we are integrating after getting the difference, and we are only integrating or getting the area of the shaded part only. After getting the difference, so we are integrating from -2 to +1, -2 to +1 dx. So we shall have this, -2. Then what are we integrating? We are integrating -2x squared minus 2x plus 4 dx all the way to 1, all the way to +1. Now, after having that, it is just a matter of now substitution. You substitute. So we shall have -2 into 1 squared minus 2 into 1 plus 4 plus 4 plus 4. Before we substitute, we must rewrite the equation. So we shall have something like this. Now integrate. What will we have? -2 over 3. -2 all over 3 x cube minus x squared plus 4x, all running all the way from -2 to +1. So from this, it is now from this point that we shall substitute. So let's start with 1. So we shall have -2 all over 3 into 1 cube minus 1 squared plus 4 into 1. You will get the answer there. This other one, we are having -2 over 3 into -2 cubed minus -2 squared plus 4 into -2. Get the answer there. So at the very first place, we shall have 2 and a third. Then this one, we shall have -6 and 2 over 3 and 2 over 3. So then we get the difference. Get the difference. So it is now 2 and a third. Subtract -6 and 2 all over 3. So our answer there will be what? Our answer there will be 9. 9 squared units, or 9 units squared. So that is that. Question 2. The following diagram shows a straight line and a curve whose equation is that one, a half x squared plus 1. The straight line intersects the curve at point A and B. If the straight line's x-intercept is -8, indicated, and the y-intercept is 4, as indicated there, give the equation of the straight line in the form y is equal to mx plus c. Give the equation of the straight line in the form y is equal to mx plus c. So guys, get the coordinates. So at x we are having -8, 0. Get the coordinate. At y we are having 0,4. Then after getting that, obtain the gradient. Gradient will be 4 minus 0 all over 0 minus, which is plus 8. So we are having 4 over 8. So that means our gradient is a half. Simplified, our gradient is a half. So pick any of the coordinates. So I'll use 0.4. I always avoid negative. There's a reason. Even in the first question, you saw me avoiding the negative because it is confusing for a student. Avoid it. So we are having 0,4, x, y. A gradient is a half. So we are having y minus 4 all over x minus 0, which is equal to what? A half. So cross multiply. 2y minus 8 equals to x minus 0. So we shall have 2y equals to x plus 8 plus 8. But in the form y is equal to mx, so divide by 2, divide by 2, divide by 2. So our answer will be y equals to what? A half x plus 4. A half x plus 4. That is it. That is it. Part B. Find the coordinates of A and B. Find the coordinates of A and B. Hence, find area bounded by the curve and the straight line. Though the space is too small for us, too small. Find the coordinates of A and B. Now, to get the coordinates, remember I told you that when two things meet, they're equal. When two things meet, they're equal. So equate the function with the equation of the line, which already we have. So it is now a half x squared. It was half x squared plus 1 equate to what? A half x plus 4. So solving this, we shall have what? A half x squared minus a half x squared minus a half x minus 3 is equal to 0. You can simplify this into, okay, multiplying by 2, both sides multiplying by 2, it will be just easy. Well, we shall have now x squared minus what? Minus x minus 6 equals to 0. Use the quadratic formula. X equal to negative b plus or minus the square root of b squared minus 4ac over 2a. Use that one to save on time. So x equals to what here, guys? Remember, this is negative. So there is no need of again indicating a negative, because now it is already positive. So we are having 1 plus or minus the square root of 1 squared minus 4 times 4 multiplied by a, which is 1, multiplied by c, which is negative 6, all over what? All over 2a, 2 multiplied by 1. So have that one in your calculator. Obviously, we will have to answer. So the first x is 3, and the second x is what? Is negative 2. Then ask yourself, if x is 3, what is y? And if x is negative 2, what is y? So remember, you can use the equation of the straight line or the equation of the function to get y. Either will work, will still get us the same answer. Now, when x is 3, y is 5.5. And when x is negative 2, y is 3. So that means that the coordinate of A, go back and check. Where do you think, or what do you think will be the coordinate of A? Obviously, the x-axis must be negative. As you can see, just from observing, the x-axis will be negative. So as from that observation, A will be negative 2,3. And B will be obviously the remaining one, which is 3,5.5. So that is the coordinate. Of A and B. Hence, find the area bounded by the curve and the straight line. Look at that question. Find the area bounded. So let me just wrap this. Now, hence, find the area bounded by the curve and the straight line. Find the area bounded by the curve and the straight line. So remember, the area bounded, the area in between the what? The curve and the straight line, that area in between, that portion, that part, this one. This is what you are required to get, the area of that. So remember, it is just getting the difference. You get the difference. So get the difference. And the difference must be, Remember I told you, it is line subtracted to curve, not curve subtracted to line. So have that in mind, So now we remember to include the bracket. I have x plus 4, minus what? Minus the curve. I have x squared, plus 1, So subtract this. So we shall have what? I have x plus 4 minus I have x squared minus 1. So having this, we shall have something like now I have x squared, plus I have x, plus I have x, plus 3, is equal to 0. Now, after having this, you integrate. From where to where? From what to? Remember at A. Always input the coordinates. I remember getting the A. Remember, I've already wrapped that point. So A was negative 2,3. So that means at X is minus 2, and B, the coordinates of B was what? 3,5.5. That means at X is 3. So you are integrating from negative 2 to 3. So integrating from negative 2. From negative 2. Then what are we integrating? We are integrating the difference of this, one, which is minus I have x squared plus I have x plus 3 dx all the way to 3. So upon integrating this, we shall have what? We shall have negative 1 over 6x cubed plus what? A quarter x squared, plus 3x all the way from negative 2 to positive 3. So let me wrap this section, then we continue. So I hope you had the previous arithmetic captured with you. So we reach at this point. Where we had negative 1 over 6 x cubed plus a quarter x squared plus a quarter x squared plus 3x. That is ranging from negative 3 all the way to, negative 2. Negative 2 all the way to positive 3. Now, after having this, now substitute. So we are having negative 1 over 6, 3 cubed, plus 1 over 4 into 3 squared, plus 3 into 3. Get the answer at that point. Get the answer for that. For 6, negative 1 over 6 into negative 2 cubed plus 1 over 4 into negative 2 squared plus 3 into negative 2. Get the answer. So this other one using a calculator, we shall have 6 and 3/4, and this other part, we shall have negative 3 and 2/3. Then you get the difference. So it is now 6. It is let me use another color here. Let me use yellow. So it is now 6 and 3/4 minus 3 and 2 all over 3. Working this in a calculator, our answer will be 10 5 over 12. 5 over 12 units squared. So sometimes the working space can be small, so you have to squeeze your answer, and it is not a must for you to write everything. Some things you can just punch in a calculator, provide the answer, punch in a calculator, provide the examiner for the answer, and at the end you will be marked right. So let us solve part C of the question. If the coordinates of A and B obtained in B above are in x1, y1 and x2, y2, find the area bounded. Find the area bounded by the curve and x-axis and the lines x equal to x1 and x equal to x2. Never be afraid of a question. Never be afraid of a question. Many students will just read this question, and just because of x1, x2, and the x1 being equated to x2 the same to that other part, they're saying like, no. Don't be afraid of a question. Always try to read and understand the question. Make sure you connect it back to what it is saying in that previous part. So as for this one, where x equal to x1 and x equal to x2. So we are integrating. That means an examiner wants us to get the examiner wants us to get the what? The area of the curve. Just simple like that. Something simple. An examiner wants to confuse you. So make sure you don't accept easy defeat from the examiner's side. So make sure you are also bold. So we are integrating. Let me use good color. So we are integrating from -2 to +3. -2 to +3. Examiner wants you to get, okay, listen, if the coordinate of A and B obtained in B above are A, x1, y1, and B, x2, y2, find the area bounded. Find the area bounded by the curve and the x-axis and the line x equal to x1 and x equal to x2. Very simple. Very simple. This is our x1. This is our x2. Very much simple. So you are integrating from -2 all the way to 3. And what are you integrating? You are integrating the curve, which is a half x squared plus 1 dx plus 1 dx. So upon integrating this, what will we have? A 6x cube plus x integrated from -2 all the way to 3. So substitute a 6th into 3 cubed plus 3. Get the answer there. Then we have a 6th into -2 cubed plus -2. Get the answer there. So for this one, we are having 7.5, and for this one, we are having -3 and a third. So get the difference. Let us have 7.5 minus -3 and a third. Solving this, our answer will be 10, 5 all over 6 units squared. Don't forget to put the units. Question 3. The following sketch shows curve y equal to x squared. The curve itself, this one, y is equal to x squared minus x minus 6, which is intersected by line. This is the line. The line is y is equal to x minus 2 at points M and N, as you can see. points M and N. Find the coordinates of M and N. Examiner wants you to get the coordinates of M and N. For you to get coordinates, remember these things intersect. And for them to intersect, I told you that for two things to meet, they are equal. So your work is to equate. Your work is to equate. Your work is to equate. Now, we are having x minus 2. We are having sorry, there is a mistake here. There is a mistake here. The following sketch shows curve y is equal to x squared minus x minus 6, which is intersected by line y is equal to 2x minus 2. I'm sorry, I made this manually. I never gotten any this question from any book. I just made this question. So when I was making this, I think I made a mistake. So correct on that, please. The following sketch curve. The following sketch shows a curve y is equal to x squared minus x minus 6, which intersected. Now it should read, which is intersected by line y equal to 2x minus 2, not x minus 2. So correct on that, Now find the coordinates of M and N. That's like I've said that when two things meet, they are equal. So your work is to equate. So 2x minus 2 equals to what? X squared minus x minus 6. So we shall have x squared minus 3x minus 8 equals to 0. Oh, sorry. Minus 6 plus 2. Yeah. Minus 6 plus 2. That one should be minus 4. That one should be minus 4. Having that, use the quadratic formula. X equal to negative b plus or minus the square root of b squared all over 2a. So we are having a, b, and c. So my x will be what? Negative, that is 3, plus or minus the square root of b squared, negative 3 squared minus 4 into a, which is 1, multiplied by c, which is negative 4. I think it's something like that. All over 2a, which is 2 times 1. Remember, the dot symbolizes multiplication. The dot symbolizes multiplication in mathematics. So obviously there will be two answers. So the first answer will be x equals to 4 or x equals to what? Or x equals to negative 1 or x equals to negative 1. Remember what does the question wants? The coordinates of M and N. So come and write when x equals to 4, what is y? And when x equals to negative 1, what is y? You can you can either use the equation for the straight line or the equation for the function. It will still give the same answer for y. So when x is 4, y will be 6. And when x is negative 1, y will be negative 4. So what do you think will be the coordinates for M? Obviously, M is running from the x-axis at negative and at the y-axis also at negative. That means that all the coordinates of M will be negative. That is, so you only have to reason. So M negative 1, 4, and N is 4,6. Part B. Determine the exact area enclosed by the curve and the x-axis. Determine the exact area enclosed by the curve and the x-axis. Determine the exact area enclosed by the curve and the x-axis. Remember, it is curve and the x-axis. Make sure you pay attention to the question. It is not a curve and a line. It is a curve and x-axis, not a line. And remember, the coordinates at which the curve is intersecting with the x-axis are not provided. So you must reason, you must think. And I remember telling you something like that whenever those points are not provided, then there's a knowledge you apply. And what knowledge was that? That at x-intercept, y is equal to 0. So that is what we shall use here. So the function itself, y is equal to x squared minus x minus 6, if I'm not wrong. Yeah. So that is the function. Now, at x-intercept, y is equal to 0. So that is the application we use here. And you must write for an examiner. Do not just say x squared minus x is equal to 0. An examiner might think you copied. So make sure you write it down. So after writing down, obviously, which I want to do here. So x squared minus x minus 6 equals to 0. But make sure you write the term or the words at x-intercept y is equal to 0 for an examiner to know whatever this student is doing. From this one, use the quadratic formula to get the values of x faster. Now x will be what? 1 plus or minus the square. I hope you know this. Guys, you know this. Please. Let me just get the values of x. So the first value of x, after solving this in quadratic formula, the x will be 3. X will be 3, or x will be negative 2, or x will be negative 2. There is no need for us to get y because we haven't been asked to get the coordinate. So up to this point, we are just right. We're just fine. Now remember, now we must integrate. We must integrate from negative 2 all the way to positive 3. So that means at this point here is negative. No, sorry. Here is negative 2. Then here is positive 3. Remember, you are integrating the curve in between the x-axis and the curve itself. So what are we integrating? We are integrating x squared minus x minus 6 dx. So we shall have a third x cube minus a half x squared minus 6x, all the way from negative 2 to positive 3. Negative 2 to positive 3. So your work is just to substitute. Now a third into what? Let's start with 3. A third into 3 minus a half into 3. Remember, this one is cubed, into 3 squared minus 6 into 3. So get the answer there. Then we have a third into now negative what? Negative 2 cubed minus a half into negative 2 squared minus 6 minus 2. Get the answer there. For the first part, we are getting negative 13 and a half, and this other one we are getting 7 and a third. So get the difference. So the difference there is negative 13 and a half, minus 7 and a third. Our answer there will be negative 25 all over 6. Remember, I told you something. These things are related. These questions are related. Whatever I'm telling you here, these questions are not just randomly picked. I'm picking these questions with a reason. I'm picking these questions with an aim. I want you to understand something. When you see negative 25 over 6, an area or the final answer of your question coming out to be negative whatever the value, know that that question, or sorry, know that that curve appears below the what? The Cartesian plane or the x-axis. That curve, its appearance must be below the x-axis, and that is why the answer is negative. So sometimes an examiner will test your knowledge capacity to what? To draw the sketch. He or she will want to see how will your sketch look like. So make sure you know that one. Make sure you have that idea. And as you can see, it is true. It is true. Whatever we are being asked to get is this one, which is below the x-axis. So even if I were to do this question and I get my final answer to be positive, I will know that I'm wrong. I will automatically know that I'm wrong. Why? Because the area I'm being required to get is below the x-axis, and my final answer must be negative. So if my final answer is negative, I'll know that area cannot be negative. So I ignore, or you ignore that negative. Therefore, the area is 25 all over 6 units squared. Understood up to that point? Let us check at the last part. Find the area of the shaded region. Find the area of the shaded region. Find the area of the shaded region. Our shaded region was this one, guys. Remember, these ones were not indicated. This black, I've just indicated that one for you. Now, the area that was shaded in this part was this one. This was the area shaded. This was the part shaded, guys. That one was the part shaded. To get the difference, obviously, you must start by getting the difference. That one is 2x minus 2. Subtract 2, x squared. That is equation of the curve, x minus 6. So doing this, we'll have 2x minus 2 minus x squared plus x plus 6. So we shall have minus x squared plus 3x plus 4 is equal to 0. After having that, we integrate. Now, guys, come back here. Come back and see something here. Remember, from where to where are you integrating? From where to where are you integrating? Or which boundary are you integrating? After you know that one, getting the values, having the correct values for you to use will never be a problem at all. I promise you. Now at M, remember at M already we had the coordinates. So at M was -1 minus 4. So -1. Then at N we had 4,6. So that means this part is 4. So guys, when you are integrating, when you are getting the area of that small part, you must integrate from M to N, the coordinate of x-axis used only. So it is from -1. And what are we integrating? We are integrating the difference of the line and the function, which is minus x squared plus 3x plus 40x all the way to what? All the way to 3. Having this, integrate this. So we shall have negative 1 over 3x cubed, negative 1 over 3x cubed plus what? Plus 3 over 2. 3 over 2 x squared plus 4x plus 4x closed minus 1 to 3. After doing this, you now substitute. My pages are defined. Okay, you now substitute this. Let me use this part. So it is minus a third into 3x cube plus 3 over 2 into 3 squared, yeah, plus 4 into 3 Get the answer there. Then again we are having negative a third into now negative 1 cube plus 3 over 2 into negative 1 squared plus 4 into negative 1. Get the answer there. So for the first part, we are having 18 and 2/3. 18 and 2/3. Then this other one, we are having negative 2 and a third. Negative 2 and a third. So our answer will be now get the difference. So our answer will be 18 2 over 3 minus 2 and a third. So doing that or solving or getting the answer to this, our final answer will be 25 all over 6 units squared. This one marks the end of the revision of what I've told you or what I had described or what we have discussed in our previous lesson. So guys, when we meet next, we shall look at trapezium and mid-ordinate rule. Very, very interesting topic. Trapezoidal rule, trapezium and mid-ordinate rule. Thank you very much for watching. And guys, if you have understood this lesson, please subscribe, share with your friends who are also struggling with mathematics. And if you are guru in mathematics, feel free to interact with me for you to become more than a guru. Thank you, and thank you very much.